Hello students, let us solve this question from the chapter waves. The question says, a siren placed at a railway station at a railway platform is emitting sound of frequency 5 kHz. A passenger sitting in a moving train A records a frequency of 5 kHz while the train approaches the siren. During his return journey in a different train B, he records a frequency of 6 kHz. While approaching the same siren. The ratio of velocity of train B to that of train A is. So we have to find the velocity of train A and velocity of train B. So let us solve this question. How do we do the solution? So this question is from the Doppler's effect. So this question is from Doppler's effect. So we can write that the frequency observed by observer is given by, this is the frequency observed by any observer, is given by the frequency emitted, the velocity of sound plus velocity of observer divided by velocity of sound minus velocity of this is the velocity of source. Now in this case, let us suppose this is a platform and it is emitting a frequency, frequency of 5 kHz, emitting frequency of 5 kHz. F is 5 kHz. An observer is approaching this platform. Let us suppose this is velocity of A, with velocity A, and it's observed the frequency observed is 5.5 kHz. 5.5 kHz. Now substitute these value in this formula. We can find the velocity of observer A. So observed frequency is 5.5 kHz. Here the observed frequency F0 is 5.5 kHz. Kilohertz is 10 to the power 3 Hertz, and this is the frequency emitting by the platform, which is 5 kHz. 5 into 10 to the power 3. Now velocity of sound is Vs plus velocity of observer is, let us suppose velocity of observer A is Va, divided by the velocity of sound minus velocity of V of t is velocity of source. So source is a railway platform which is not moving, so its velocity will become 0. Now we can cancel some equal terms, so this will become 5.5 divided by 5 equals to velocity of sound plus velocity of A divided by velocity of S. Now rearranging this term, we can rearrange this term as velocity of sound plus velocity of A equals 55 divided by 50 into velocity s. Now we can send this velocity to right hand side. So velocity of a will become 55 divided by 50 vs minus vs. We can take the vs as common, so this can be written as 55 divided by 50 minus 1. So this will become vs 55 minus 50 will become 5 by 50, and this will become vs by 10. So this is the velocity of observer A. Now during the return journey, it is coming with another train which is B. Let us suppose this is train B and this is going towards the platform. So again we have to write the same formula. So frequency observed in this case is 6 kilohertz. 6 kilohertz. The original frequency emitted by platform siren is 5 kilohertz. Velocity of sound plus velocity of observer is b, divided by velocity of sound minus velocity of source, which is platform. So this velocity is 0. Again we can rearrange the term 6 by 5 v of s plus v of b divided by v of s. So rearranging this term, we can write v of b equals to 6 vs by 5 minus vs. So vs can be taken as common, 6 by 5 minus 1. So you can write vs into 6 minus 5 equals to 1 by 5. Okay. Now we have to calculate the ratio of velocity of train B to that of train A. So we have to calculate the ratio here. V of B to V of A. So velocity of train B is Vs by 5, and velocity of train A is Vs by 10. So this will cancel out as, so Vb by Va is calculated to be 2. So this is the ratio of the velocity of the two trains. This is the ratio of Vb upon Vb is 2. So which option is correct? Second option is the correct answer to this question. Hope you found the solution understandable. Thank you.